Dear friends, in this video, we will look at an application that involves bivariate population t-test, which are paired. In other words, we have got two populations that are related in some way. And we can apply the t-test in a nice way and interpret the results. Let's look at the problem. A company conducted a promotional campaign in 10 randomly chosen retail outlets. Monthly sales in 1,000 units are shown before and after the campaign. Was the campaign effective? That was the question. Sorry for the small typos here. The P here is a little extra. It's campaign. Was the campaign effective? We have data on sales before the campaign and after the campaign. And mind you, because it is related population, the sample size in both the groups must be equal. And we have to state that the populations are related in the Python coding. So let me just say these are the numbers: 240, 225, 250, etc., 170. Similarly, after the campaign, the sales have improved. It looks like that: 270, 245, 260, 290, etc., 175. From the wording of the question, was the campaign effective? It's possible for us to conclude, was the campaign effective? The null hypothesis is the mean sales were same before and after the campaign, status quo. The alternative hypothesis, the mean sales increased after the campaign than before. So, was the campaign effective? We have formulated the null and the alternative hypothesis. It's a one-tail test and the right-tail test. Import pandas as PD as before. From SciPy, import stats, import statistics. So let us execute the command one by one and interpret the results. Run. So I have imported the necessary libraries. Now I enter the data before campaign, after campaign, the 10 sample observations in the 10 retail stores, 240, 225, 250, etc., 170. After the campaign, 270, 245, 260, etc., 175. Mean before campaign, mean after campaign I take, and just out of curiosity, we compute the mean sales using statistics function, statistics.mean before campaign. Of course, I have put an underscore here just to indicate it's a variable. Then I'm rounding the mean before campaign to 4 decimal places for readability. Then I'm printing the mean sales before campaign. Similarly, I do mean after campaign, statistics.mean after underscore campaign. And I round the mean after campaign to 4 decimal places, and I'm printing the same mean after campaign. Let me execute this now. So the mean sales before campaign is 191. Mean sales after campaign is 201.5. Prima facie, it looks the campaign has been effective. In other words, there is an improvement of 10 units. Each unit is 1,000 unit sales actually. So the sales have improved by 1,000 units, 10,000 units, sorry. But is it statistically significant? We'll have to see this difference so that we can conclude the increased sales is not only practically significant, but statistically significant. Unless it is statistically significant, we cannot say the campaign has been effective. Now we come to the execution of the t-stat, t-stat1, stats.t-test underscore relative population, REL, we'll have to mention. After the campaign, underscore, after underscore campaign, comma, before underscore campaign, and we say alternative is equal to greater, because by default Python will do the two-tail test, and we need the single tail, right tail test, alternative greater you'll have to put. Then tstat1 I compute, then I declare it as a data frame for better readability of the output, pd.dataframe tstat1. I name the column as result, then the tstat1.index, that is naming the rows, I put tstat and the p-value. Then I'm rounding the tstat1 result to 4 decimal places. Let me execute this command. I get the result. The computer tstat is 2.5120 and the p-value is 0.0166. Since the p-value 0.016 is less than alpha, which we take normally as 5% when nothing is specified, we conclude H0 is rejected, 0.0166 is less than 0.05, and therefore the alternative is accepted. In other words, we conclude the mean sales increased after the campaign than before, which means the campaign was effective. In order to understand it is a one-tail, right-tail test, I have diagrammatized the t-distribution for 9 degrees of freedom, and the computed t-stat 2.5120 is here. The p-value is probability t greater than 2.5120, which is equal to 0.0166, and therefore we have concluded the null hypothesis is rejected, the alternative is accepted, and we conclude the campaign has been effective because the mean sales increase is statistically significant, and hence we conclude the campaign was indeed effective. Thank you very much. I hope you have gained some knowledge. We will see you soon in another video.